So we've talked about uncertainty, and how to handle your answer, what kind of uncertainty your answer will have if you're adding and subtracting measurements that contain uncertainty. And we've talked about how to handle what your uncertainty will be for your answer if your measurements are going to be multiplied and divided. So now we're going to look at, well, what happens if in the calculation you have to add, subtract, and multiply, divide. So I'm going to call that one a complex uncertainty because it's got both types in it. And then we're going to finish this off by talking about the real significant figure rule. So at the beginning of this chapter, and in Gen Chem 1 and Gen Chem 2, you learned sig fig rules that you had to follow for addition, subtraction, multiplication, division, logs, and anti-logs. But those were all a simplification of the real sig fig rules that you weren't ready for. But you're going to be big enough kid chemists now to know the real sig fig rule. So we're going to get there at the end. So let's look at our complex uncertainty problem. So in this one, I've got 0.4931 grams. It's going to be added to 1.229 grams. That then needs to be divided by 0.889 milliliters. So we're solving for a density here. But all of these measurements have uncertainties in them. Okay, so our answer is going to be something grams per milliliter plus or minus the uncertainty in grams per milliliter. And we're also going to need our answer, grams per milliliter, plus or minus our uncertainty as a relative uncertainty. Well, we can get these two numbers by just looking at this, and this. So I'm going to take 0.493 plus 1.229. Those were in parentheses, so I know I had to do the additions first. And then divided by 0.889. So if I'm following the sig fig rules that we learned earlier, this has 4 sig figs. Actually, it has 4 decimal places. And this has 3 decimal places. And then this has 3 sig figs. So my answer would be 1.93. And then I'm going to keep 712 along for the ride. Okay, so what we need to do now is look at the uncertainty. Well, so I've got addition right here, and then I've got division right here. So we're going to have to just break this problem into parts, and we're going to go in the order of the mathematical operation. So in this problem, we do the addition first because there are parentheses. So we're going to break this problem in half and just look at just the addition part of it when we're looking at the uncertainty. So the addition part of it when we're looking at the uncertainty, I'm going to rewrite just the addition part. It was the 0.4931 grams plus or minus 0.0004 grams. That number plus 1.229 grams plus or minus 0.001 grams. So I just took the numerator. Okay, that's the addition part. And again, we're going in order of operations. So you don't always start with the addition. You do whatever math you had to do first. Okay, so what we're going to do is just figure out the uncertainty for just this step. So it's going to be, again, number in grams plus or minus number in grams plus or minus the percentage. So I can take 0.4931 plus 1.229, and what I have is 1.7221 grams. I have it rounded here. And then to get my uncertainty, well, this is addition. So we're following the addition subtraction rules. So the uncertainty is going to look like this. And with addition subtraction, they have to be absolute, equal sign there, absolute uncertainties. So the good news is these are already an absolute uncertainty. So I'm going to take 0.0004 squared plus 0.001 squared, and then square root it. And when I do that, I end up with 0.001. And so the unit would still be grams because these are absolute uncertainties, 0.001 grams. Now, if I want to convert that to relative, because I like to have everything, so there's the absolute uncertainty and here's the relative uncertainty, then the percent would be the absolute uncertainty, 0.001 grams, divided by the value, 1.7221 grams times 100. And when I do that math, I get 0.06% relative uncertainty. Okay, so what I've done is I've kind of simplified this problem. This part of the problem is now gone. Okay, and instead I have 1.722, and really it would be a subscript 1 because 3 decimal places, 4 decimal places, plus or minus 0.001 grams divided by, the rest of the problem was 0.889 milliliters plus or minus 0.002 milliliters. So I'm just going through this problem one step at a time. I took this and I did the numerator and replaced that with the answer that I got for the numerator. And now we're ready for the division step. Okay, so I wrote that there, and then I'm going to have to really turn around and write it here. What was it, 0.001? And then it was 0.889 milliliters plus or minus 0.002 milliliters. Okay, so now we need to get our answer, which again, there's going to be number in grams per milliliter plus or minus the uncertainty in the absolute uncertainty in grams per milliliter, and the number in grams per milliliter plus or minus the relative uncertainty as a percentage. Well, I can take that first number by taking 1.7221 divided by 0.889. 1.93, so it was really, 3712. So 3 sig figs, so 1.94, but I don't want to round it yet. So now I need to find the E final, okay, the uncertainty. Well, with division, we have to do this equation, with the percent relative uncertainties. So these are both written as absolute uncertainties. So I need to convert them into relative uncertainties. Well, the good news was we actually did this for the numerator on the previous slide, where 1.7221, make the one little, grams plus or minus 0.06. We'd already calculated what the relative uncertainty was. For the denominator, we're going to have to solve for the relative uncertainty by taking the absolute 0.002 milliliters divided by 0.889 milliliters times 100. And when I do that, I get 0.2%. So the percent relative for my final answer is going to be 0.06% squared plus 0.2% squared. And again, when I do this in my calculator, 0.06 squared plus 0.2 squared. You're not going to do anything with the percent. That's just showing the symbol. So my answer is 0.2. So that means this goes right there. I have my relative uncertainty. Now I'm still going to have to convert that into absolute uncertainty. I need a number there. So what I need to do is calculate, well, what is 0.2% of 1.93712? Well, let's take 1.93712 times 0.002 to figure out what is 2% of that, which is 0.00, hold on, 1.93712 times 0.002, so 0.004. And this will have the units of grams per milliliter. Okay. So now I've got my absolute uncertainty and my relative uncertainty and my final answer. So this right here will be my final answer. Okay. Now we're going to come back to this in just a second because I want to look at the final sig fig rules, and then we're going to come back and apply that here. So that number 1.93, we had said we really should round it to 3 sig figs because of the way the math worked out. So 1.94 would be my answer. So that's what we think. So I'm going to say 1.94 gram per milliliter plus or minus 0.004 grams per milliliter would be my final answer with the absolute uncertainty on it. Okay, so we're going to come back to this. So this is just a table from the textbook showing you that it is possible to do this for things. So there's addition, subtraction, multiplication, division. That's what you're being held to. But here it shows it for anti-log and log, natural log, and the inverse of natural log. So it's given you some other options. I'm not holding you to those, but I wanted to show them to you in case in a later point in your academic or career you need to learn or you need to do this. It's possible, and if you can do it for addition, subtraction, multiplication, division, you can do it for anything. So Just showing you the table that's giving you that information. Okay, so last, what's the real rule for significant figures? So this is the rule that you were not taught in Gen Chem 1. You were not taught in Gen Chem 2 because you didn't actually know enough to understand that answer. So the real sig fig rules, it's the first digit of the absolute uncertainty is the last significant digit in the answer. So in this one, we're going to go with, these don't have units. I don't know why I didn't do that. Grams per milliliter, grams per milliliter. So I did the math to convert this uncertainty and this uncertainty into this. Okay. So that number came from me using those two. And then I took that number divided by that number. And if we looked at this number divided by this number, this had 4 sig figs, this had 4 sig figs. So based on our sig fig rule, this should have 4 sig figs. Well, based on the real sig fig rule, we need to look at the absolute uncertainty. So this is my answer of the absolute uncertainty. It goes to the 1, 2, 3, it's 4 decimals to the right. So your answer, the first digit of the absolute uncertainty, so that right there, is the last significant digit in your answer. So this goes to the 4th decimal place is where my absolute uncertainty happens. So that means this answer is only significant to the 4th decimal place, which actually makes it have 3 sig figs because 0.0946 goes to the 4th decimal place. This sig fig rule only works if you have absolute uncertainties to work with. In Gen Chem 1 and Gen Chem 2, you didn't have absolute uncertainties to work with. So all of the other sig fig rules, the sig fig rule about addition and subtraction, about how you count decimal places, and your measurement that had the fewest decimal places is how many decimal places your answer gets. And for multiplication and division, when it's your sig fig, so you look at all the measurements that you multiplied and divided, and the one that has the fewest sig figs is how many sig figs your final answer has. Those rules are all trying to follow this real sig fig rule. They're like a shortcut trying to get you there that are usually right, but not always right. So based on this, I'm going to go back to the calculation we just did. There's my answer with its absolute uncertainty. So the absolute uncertainty goes to 3 decimal places. So that means my final answer really needs to go to 3 decimal places as well. So what it really should be is 1.937 gram per milliliter plus or minus 0.004 gram per milliliter would be my actual final answer. So now that we know that rule, what that means, when we're doing these problems with the uncertainty, don't round your answer like this number. Don't round it at all until you're all the way done and you have your absolute uncertainty, and then that's going to tell you how much to round it. So when you're doing these problems, when you take your, not the uncertainty part, but the other number part, just write the whole thing down. And it's not until the end that you're going to round, because the actual absolute uncertainty of your final answer tells you how much of that number you get to keep. So now you're big kid chemists. You know the real sig fig rule. And again, we can only actually follow the real sig fig rule when our measurements have these uncertainties after them. You're not going to always have uncertainties after them now, just because we learned about it, but we absolutely will often.